Okay, today's question then is on the equation of a line. So here it is. Let's have a quick read through it. L2 is the line with equation 2y minus 3x is equal to 10. Find the equation of the line L1 that is parallel to L2 and passes through the coordinate 4, 12. Okay, so two things. This straight line here, although it's given to us in this form, we've got the equation, we want it probably to be in the form y equals mx plus c. So the first thing I would do is rewrite that. That's the first thing. And the second thing is make a sketch, right? So once you've done that, try and make a sketch to help you visualize what's going on, all right? So give that a go. We'll catch up in a few seconds to go through the answer. Rightio, let's go. Now then, the first thing, as I did mention, is that we should probably rewrite this in the form y equals mx plus c, right? So the general form of a straight line. So let's do that. So 2y minus 3x is equal to 10. And I can say 2y is therefore equal to 3x plus 10 if I shift that over to the other side. And then I can go y is equal to, now divide everything by 2, so I can say 3 over 2x plus, and 10 divided by 2, 5. There we go. So this here is probably the form that you want it in, right? And what information we can get from there is that the gradient of this line is 3 over 2, or 1.5, whichever you want to go with. So we've got the gradient. Now let's make a sketch, like what's going on here. So we've got an axis here. This line here, it's got a positive gradient, firstly, and it passes through 5 on the y-axis. So its y-intercept is 5. So if I put this here as 5, and then just draw a line with a positive gradient, that there is this line L2. Now what we've got to do is, we've got to find the equation of a line which is parallel to it and passes through the coordinate 4, 12. Okay, now if it's parallel, what does it mean? It means it's sloping in the same direction, right? So something like that. And it's going to go through this coordinate 4, 12. So 4, 12, I don't know, where should we put that? I'm just going to put it here and say that this here is that line, L1. And what we've got to do is find the equation of that line. Now, because they are parallel, it means that their gradients are the same. So it means that the gradient of this line here, L1, let's go here, grad, we'll put gradient as grad, is equal to 3 over 2 as well, or 1.5, as I said, whichever you want. And what we would need to do then is find its y-intercept, right? We've got to find what c is in that general form. So y equals mx plus c. So we've got the gradient, but we don't quite have the y-intercept, so we'll need to work that out. How do we work it out? Well, we can start to fill this out like this, right? Because we know the gradient is 3 over 2, so I'll fill that in. But now what I could do is, we were given a point, 412, that lies on that line L1. So let me just label that here as well. Look, 4, 12. And now 4 is an x coordinate, 12 is a y coordinate. So what can we do with this? We can take it and we can plug it in to our equation over here. So what we'll get is 12 is equal to 3 over 2 times by 4 and then plus c. Let's simplify that down. So 12 is equal to, that there's going to be 6 plus c, and therefore c is equal to 6. So what we're saying is that this here is actually traveling through 6 on the y-axis. And now that we found what c is, we can give the equation of the line, right? So we can say that it's y is equal to 3 over 2x, or 1.5x, and then plus 6. And there we go. That's the equation of that line there. Perfect. So, nice easy question there on parallel lines. Hopefully you've got that correct. And if you didn't, I hope you know how to do it now. I'll put out a few more of these very, very soon, and I hope to catch you in the next video.